Math with Oscar class. That's my dad.
Hey guys, we're going to be looking now at section 1.4, which is focused on angle pairs. So we're going to start with some basic vocabulary to get us rolling, and then we'll get into the problem set shortly thereafter. The first pair of angles we're going to look at are called adjacent angles. And as you can see by the definition, it refers to two angles in the same plane with a common vertex and a common side, but no common interior points. It helps to look at a picture, so let's pull that up next. In this diagram, angles 1 and 2 represent adjacent angles. You can see the common ray between them. Angle 1 and angle 2 also both start at the same point. Now likewise, angles 3 and 4 are also adjacent angles. There's that common ray between the 3 and the 4, and they all start at that exact same point. So both of these are illustrations of that adjacent angle, angles that are effectively next to each other. Next up, we're going to talk about linear pairs. Now this is a subset of adjacent angles where the non-common sides are opposite rays. Remember, an opposite rays are two rays that have a common endpoint and shoot off in opposite directions. So in this case, if we look at angles 3 and 4 in a different light, you can see that the ray that does not make up the common ray between them, they make up opposite rays, or they form a line. The easy mnemonic here is that linear pairs form lines. So for two angles to be a linear pair, you need to see a single line somewhere. Another pair of angles that we're going to look at are called complementary or supplementary angles. These are angles that add to 90 or add to 80 degrees, respectively. There are many tricks to remembering these. For example, if you add a line to the C in complementary, you can see a 9. Or if you draw a line through the S, you can see the 8 of 180 in supplementary. The big idea here is that complementary angles add up to 90 degrees, and supplementary angles are going to add up to 180. A common thing with complementary or supplementary angles is to draw them in a way that looks somewhat natural. We can see that and see it's 90 degrees. So if I add another ray in here, I can easily see that I have two angles that are going to add up to 90, a 30 and maybe a 60. And since 30 degrees plus 60 degrees equals 90, it checks out. I'm writing it this way on purpose because I want to emphasize what we've been working on before, which is the idea that the part plus the part equals the whole. Now that's the segment angle addition postulate we've been playing with. Also the segment addition postulate, but in angle form. And the key with complementary and supplementary angles is to approach it exactly the same way. Think of it in that context of part plus part equals whole, except in this case, if I use the term complementary, if I'm talking about complementary, I'm talking about the whole being 90 degrees then. If I bring in supplementary, for example, in that case, the whole would be 180 degrees. So again, in this context with these angle pairs, you want to be thinking about the two parts equaling the whole like we have been, but now we have a special term, complementary or supplementary, for those special cases where we know exactly what that outcome is going to be. Alright, so here it says that angles A and B are complementary. A is 40, B is unknown. So the typical assumption most students will say is, well, we know complementary means 90, and they'll dive right in and subtract off that 40 and get an answer. And that works. The problem is it's still getting away from where these problems could get hard. So I'm going to continue to encourage you to do this, which is to instead write 40 plus x equals 90, and then subtract your 40 from both sides so that you have your x equals 50 degrees. And what that will do is it will set you up later for success when these aren't going to be hard-coded numbers. Let's take another example. Angle C and angle D are, it says, supplementary. Now remember what supplementary, if I draw that line in there I can see an 8. But down here it's a little easier to see. There's the S in supplementary, Now it's an 8 as in 180 degrees. So it says these two angles are going to be supplementary. One of them is x plus 40. The other is going to be 3x plus 20. Let's say the question then asks, what is the measure of angle C? Now, as I've said before with these problems, it's not good enough to simply go, oh, it's x plus 40 and call yourself done. You can, you're just not going to get any credit for the problem. So, I mean, one of you might if you're the first one and I laugh at it, but then when I'm done laughing, nobody else gets credit. So why bank on being the first one I happen to grade? That's not a good strategy for life. So, we need something better as far as long-term strategies go. And as I've said before, we're going to set this up the same way we set up angle addition. Part plus part equals the whole thing. Let's get over where we have some room to work. All right, let's write this out now. X plus 40 plus 3x plus 20, all of that is going to equal 180. Let's get that where we can see it. Okay, now it's an algebra problem. X plus 40 plus 3x plus 20 is 180. So since I'm still on one side of the equal sign, I'm going to combine my like terms. Now be real careful. When you're working on one side of the equal sign, you're not adding to both sides of the equal sign. You're just merging your like terms. So x and 3x is going to become 4x. 40 and 20 is going to become 60. That equals 180. Subtract the 60 from both sides. So 4x is going to equal 120. Therefore, x is 30. Now, I still haven't answered the question that was asked, which is, what is the measure of angle C? I know x is 30, but that's not enough to call myself finished. If I come back over here and look, it said C was x plus 40. So that's going to be 30 plus 40 for a final answer of 70 degrees.
You wouldn't have an extra toothbrush, would you?
Alright, our last pair of angles are vertical angles. Now these are two non-adjacent angles formed by two intersecting lines. It sounds a lot more confusing than it needs to be, but you should probably write down the actual book definition for your notes first. Pause if you have to. If we take a look at the picture, it tends to make a lot more sense. If you notice in this diagram, angles 1 and 2 are adjacent. They share that common ray there, and they're a linear pair. Their non-adjacent rays make opposite rays. So when we talk about vertical angles, we're looking for the non-adjacent angles, angles like 2 and 4, or angles 1 and 3. The key to vertical angles is that if you think of the V as an arrow pointing down, it's sending you kitty corner across the picture. So vertical angles sit kitty corner from each other on opposite angles. So like the northwest and southeast corner of an intersection. Alright, so you've got vertical angles, linear pairs, supplementary, complementary, and adjacent. Make sure you got those ready and be looking forward to some problems next time we meet. Say bye, Miles. He just wants to eat. Say bye-bye.